So part of our standard is trying to find probabilities using the normal distribution curve. So if you're given a problem that states that the data is normally distributed, all it's telling you is that that data shapes a bell curve, and remember, beneath the bell curve is 100% of the data. So within this curve, it has an area of 1 or 100%. Okay? We also learned with the empirical rule, the 68, 95, 99.7 rule, that data lies within certain standard deviations away. So I know that 1 standard deviation, 2 standard deviations away in either direction, there's a certain amount of data. But how do we figure out how much data lies if it's in between 2 standard deviations? In the past, like how I was taught was how to use a table of values. So essentially you would find the value, you would go to the table, it would tell you how much percent lies within the data, but we have Desmos, we have technology that can do it for us. There's a way to do it in the TI calculators, but I'm going to teach you how to do it with the Desmos graphing calculator. Alright, so there are 3 categories of questions. There are more questions, so if I ask you for what is the percent of people that are taller than this data value, or what is the percent of people that have a higher chance of getting struck by lightning. It's just a more question, something that's higher or bigger. The probability of x being greater than a number. When that happens, you're going to find the data point of x on your normal distribution, and this is just going to be a sketch. You don't have to have a specific number. Just kind of identify the mean and then identify where your number was. So let's say my number was right here. Just to sketch it out, this is what your curve should look like if you highlight the curve to match a more question. It's going to be anything above. Now when we're using technology, because it's something asking us to go above, then I know that I'm going to have a minimum value. Whatever the number was that was given, that was stated in your question, and we're going to go over some examples, that number will be a minimum value. Because it's the smallest number, it's a minimum number if you want the probability of things that are above it or more than it. Okay, so that was a min. Now, less than questions, so if I give you a less than question, or a smaller than, or shorter, or anything that's hey, what percent of people are shorter than this, or what percent of people have less than this? Well, that's the probability that x, whatever your x value is going to be less than that number. X is the random variable, so if you pick a random number, what's the probability that random number will be less than the number indicated? So obviously a less question is going to be anything below your number. So let's use the same number, that pink line. Anything below that number is here. So what's the probability that you will pick a random person and they will be less than that number? Well, what's going to happen there is that number that you've identified becomes the max. I know it's a less than question. You're going to think that it's going to be a min, but it's actually the maximum. Now, last but not least, you have your betweens. So what is the likelihood that a number, a random variable x, will be between 2 values? So between a height of 10 and 14. Well, you're going to identify your 2 endpoints, so 10 and 14. Your answer, it's asking you to identify any of the people, like what is the probability that if you picked someone randomly in this entire population, that they would be between those 2 numbers. So what ends up happening is you have a minimum and you have a maximum. And it goes in numerical order. So this would be the low number and the high number. Okay? These here are just notations that might pop up in your practices. So this is just a notation indicating that it's a less than, a more than, or a between problem. It's just a notation. It's not anything. It might look a little scary, but it's actually just a way to symbolically represent what the question is asking. Okay, let's go through an example so I can show you how to use Desmos to calculate probabilities. So first of all, let's say our mean is 10 and our standard deviation is 2. Okay, what is the probability that if you pick a random number x, that it will be more than 5? So obviously this is a more than problem, so I'm going to have a minimum value, and that minimum value is going to be 5. So to use Desmos, I'm going to go to my Desmos graphing calculator. I can either type the words in. I'm using my iPad, so it's kind of hard to type the letters. So you can type the words that are going to pop up, or you can go to Functions, select Distribution, DIST, and then select Normal Dist, and you get this prompt that comes up. Notice below it says the mean equals 0 and the standard deviation equals 1. Well, all that's saying is telling you the order, that the mean goes first and then the standard deviation goes second. So I go back to my problem. My mean was 10 and my standard deviation was 2. So in this parentheses region, I'm going to write 10, comma 2. If I select the magnifying glass, it shows me what my curve looks like, maximized, so that I can see what the shape and distribution is. If I select the checkbox, it allows me to calculate the cumulative probabilities. So notice this is where it has a min and a max. Depending on the problem, you're going to either type a min or a max. Obviously, for a more than problem, you would type a min. For a less than problem, you would type a max. And if it's between, you would use both. You're not going to type in 0 or anything if it's not there. You're just going to leave it blank. It automatically fills in what you need if it's blank. So because this is a less than, or a more than, I'm going to select minimum, and I'm going to put my minimum value of 5. And it shows me that my minimum value of 5, anything above that, there's a probability that it will be, there's a 0.9938 probability that I will select a number and it will be larger than 5. So that was 0.9938. I'm going to write a 0 because it looks a little bit better when I do it like that. Okay, let's try another one. Alright, what about, let's say my mean is 110 and my standard deviation is 14. What is the probability, or what percent of people, I'll say not people, let's say the data is less than 100. So here, notice I've got my mean, my standard deviation, and a less than 100. So if I wanted to write that symbolically, it would be the probability that a data point is less than 100. Okay, so I'm going to go to my normal dist and I'm going to change this. My mean is now 110 and my standard deviation, comma standard deviation, is 14. I want to find the probability that a data point is less than 100. Okay, so the probability given in this decimal here is 0.2375. But if the question asks you specifically for percent, all you have to do is change that decimal, to a percent. So move the decimal twice to the right, you get 23.75%. So all that's saying is in this population, 23.75% fall lower than 100 or less than 100. Okay, I'm going to do one more example, a between example. What is the likelihood a data point will be between 17 and 18 if the mean is 16 and the standard deviation is 1.7. And we're going to assume that somewhere in these questions that it's stated that it's a normal distribution. So the likelihood a data point will be between 17 and 18 if the mean is 16 and the standard deviation is 1.7. There's no guarantee that your information will be given in order, so just make sure you're putting in the pieces correctly. So the probability is written as, it goes from 17 to 18, written as an inequality. So I would put in my mean, which is 16, and my standard deviation, which is 1.7. And then I would put my minimum value of 17 and my maximum value of 18. Notice it shows me the region in between those two values. 17 is down here and 18 is down there. My probability is 0.1585. So the likelihood is just asking for a probability. So what is the likelihood is the same thing as if I asked what is the probability. If I asked for the percent, it would be 15.85%. And that's how you calculate probabilities using Desmos and the normal curve.